name's Peter Elger. I'm one of the co-authors of AI as a Service, and with me this evening is Eóin Shanaghy, who's the brains of the operation. What we thought we'd do for you this evening is to walk through our cat detector workshop, which is chapters 2 and 3 in the book. And we've kind of broken this out into a 10-step workshop. So we're going to be walking through that and live deploying the system onto AWS. The code we're going to be running today and deploying is available in this repository here. So feel free to go and clone that repository and work through that in your own time. For convenience, we have created a Docker container which has all the tooling set up for the workshop. This is the repository on GitHub, so I'm going to be working through the instructions on here, but we'll take some time to really look at the code in more detail. So there is a file, there's a README called quicksetup.md if you're impatient and just want to get going. We'll take it a little bit slower and explain things in a bit more detail. So what we're going to build in this workshop is a serverless image recognition system. And we'll be touching on a number of different AWS technologies, including S3, Lambda, SQS, and of course, Rekognition, which is one of Amazon's AI-enabled image recognition services. The UI that we're going to ultimately deploy looks a bit like this picture here. And here, of course, we've used it to detect images of cats. For the workshop, if you want to work along with it now, or if you want to work along with it later, you're going to need Docker installed to run the convenience container. You will need an AWS account and also AWS API access keys. But we'll take you through how to configure that and get that set up now shortly. If you have those prerequisites, it usually takes a couple of hours to complete, but it's not a race. There's 10 steps. And of course, we welcome and value any feedback you might have. You can reach us at fortheorem.com. You can email us at the link there. You can tweet either of us, or of course, reach us on LinkedIn. Okay, so let's walk into step 1 then. We're just going to have a look at an overview of the system and what we're going to be building in a little more detail. So we've basically broken it up into 4 different sections. Section 1 is overview and setup tooling to make sure that everything's good to go. Section 2 is looking at the serverless framework, the underlying infrastructure that's going to support the system, and also some of the capabilities of AWS Rekognition. In section 3, we'll look at the asynchronous services, which form part of the system. And in section 4, we'll deploy the upper layers of the system and finish with a finished UI. That's the end goal. We've already seen that. And here's the architecture for the system. So at the top, we have a single page application that sits in the browser, and that's going to talk to an API gateway, which we're going to deploy. That API gateway is going to talk to some Lambda functions, and that's going to be a synchronous calling pattern. Those Lambda functions are going to either return data for displaying in the front end or kick off analysis jobs by posting messages into an SQS work queue. Those work queues are going to communicate either to the crawler service, and the crawler service is going to go and fetch images from a page for analysis and put them into S3 down here, or the analysis service, which is going to pick up those each of those images that's been downloaded, feed it into Rekognition, get back some data, and store the results from the image recognition into the S3 bucket. And then those results are going to be made available for processing on the front end through our API. So it's a fairly standard tiered web application built using serverless. I suppose the interesting piece is really the Rekognition service and ultimately deploying a fully serverless web application. For this, we're going to be using the serverless framework. And well, don't worry, we'll walk through the serverless framework, how that works if you're new to it, so that we're not making any assumptions here. So let's crack into step 2 then, which is getting our tooling set up. As I mentioned, we've created a Docker container for convenience. So let's just go over how we're going to work with that in building the system. So we put a bunch of tools in that container. So Python 3.7, a Jupyter Labs server, the AWS command line interface, Node.js, and also the serverless framework. And the image below kind of shows you how we're going to be working with that. So we'll be working using the command line, and our command line will be hosted within the Docker container. That means we'll have full access to all of the tools inside the container. That is then going to serve up some notebooks, and we'll do some testing in those notebooks. And of course, we're going to use the serverless framework and the AWS CLI to deploy our application up to AWS, and we'll be able to then access that through a browser. So hopefully that's clear. So to get started, what we need to do is clone the repository. If you haven't cloned it already, go ahead. If you haven't set up Docker, you'll need to set up Docker, and then pull that container, Docker pull Pelger AI as a service. Once you've got the just alternatively, you can build that from scratch if you wish. There's a Docker file there, and I'll go through that in a second. However, it's probably going to be quicker just to pull the pre-built container. It's probably not the most efficient Docker file. I would confess to that. It could probably be made a little more efficient in terms of the layers. So let's flip over to some code over here. So this is actually the Docker file. So as you can see, all it's doing is installing a bunch of tooling and so on. And then what happens when you start the container is it'll run a script called start.sh. So if we look at that, what that's going to do is it is going to cd into our home directory. It's going to spin up a Python virtual environment. It's going to run a little script to check bucket names, and I'll come to the configuration for that in a moment. And then it's going to spin up our Jupyter Lab server. And we run all of that with a script called run.sh. And all that does is to run the container, exposing port 8888 to the local machine, and sleeps for a little bit to make sure everything comes up okay, and then runs a docker exec -ti workshop bin bash. So what that means is connect to the container with a bash shell. So we've just automated all of that for you. So what I'm going to do is I'm going to now in the container directory. So if you're not familiar with Jupyter Labs or Jupyter Notebooks, they're really an excellent way of building interactive presentations and kind of data science investigations in a kind of very easily usable format. So they come out of the kind of Python world. In this example, we're going to be using JavaScript, purely because JavaScript's my favorite language at the moment, but we like Python as well. And they're just a really useful and easy way of kind of capturing ideas and code and being able to interact with data and code in a useful way. Is that a reasonable description, Owen, do you think? Or you'd probably do better than me on that, would you?
Oh, no, that sounds good. I mean, it has a great place in teaching and sharing content in general, like sharing code, because you can share documentation and the code and run it together in the one browser window.
Absolutely. And I think the other pro tip, which you've been using recently, is the use of Voila with notebooks. Voila is just a really nice way of turning your notebooks into UIs for, I suppose, non-technical people to use. So it's a very powerful tool. Okay, so apologies for slight disruption there. Hopefully you can all see my console window okay and the code is readable. So what I'm going to do then is I am going to actually start my container. So to do that, you need to cd into the container directory and run the script. Run.sh in a bash shell. If you're on Windows, there's also a batch script to start the container. Everything else, of course, should be fine from there if you're using Windows, because you'll be running in a Linux environment within the container. So whilst that's just starting up, I might just make a note on how we configure the container. So you'll find in the workshop in the container directory a file called run.env.template, and in there, this is an environment file. You'll find a number of settings. So the AWS access key ID, secret access key, the default region, and AWS region. Both of those have to be specified. That's just a slight foible between the AWS command line interface and the Node SDK. One uses one environment variable and one uses the other. You'll also need your AWS account ID. You can leave the crawler queue and the analysis queue settings the same, but you'll need to set a bucket name. And if you're familiar with AWS, you'll know that bucket names have to be globally unique. So we suggest that you pick a unique bucket name. So what I've done, if I switch back to here, is that, and there's instructions in the README for all of this as well. Use something like your last name, your company name, and today's date. That way you'll be more likely to get a unique key for your bucket. So if you've put all of those settings in and start your container, you should see something like that coming out in your container output. So that's telling me that my bucket name is available and I'm good to go. And it's also started up the Jupyter Notebook server. But of course, it's decided not to display the output correctly. So I just need to grab that. So
you're just trying to display the output in the log for that Docker container.
That's right. Yeah.
So you can grab the Jupyter URL.
That's right.
Yeah. So other people might have to do that as well.
Normally it works fine, but of course, as soon as we start the Twitch stream, I decided not to. So the reason for that is that you need, when Jupyter starts up, what happens is it generates a unique token. And you can only access with the URL with that token in place. And that's a security measure to stop people from running notebook servers and anyone being able to access. Okay, so let's paste that. If we then paste that URL into a browser, we'll see our notebook load, or our Jupyter Labs load. Great, there we go. And that you'll see all of the different steps for the workshop in there. And if you click on the navigation on the right, you'll see in step 2, there's a notebook called step2.ipynb. And this has a little bit of text in it. And it also has some code in there. So what we're going to do now is go back to the instructions. So once you've got your container running correctly, we're just going to double check everything. And we're going to double check that by just listing buckets using the AWS CLI. So if I go back to my container window here, which is running here, I'm going to do AWS S3 ls S3 : / and that's going to list any of the available buckets that I have in my account that I'm connected to. If you haven't got any buckets, you'll just get back no response. But if it's configured incorrectly, you'll get an error message back. Then what we're going to do is just to confirm everything's okay by running this script in our notebook. So this is going to do exactly the same thing, but using the AWS SDK. So here we're saying require the JavaScript AWS SDK, create an S3 object, and then use that object to call the list buckets operation, and then print out the data that we get back, and we should see no error. So you can run the code by pressing the run button at the top of the notebook. And in a moment, there we go. So we get back no error and the 2 buckets that we already saw listed in the command line. So we are good to go now, thankfully. If you do start the container and you see an error message similar to this, typically what it means is that your bucket name is already taken, in which case we've provided a little script called check bucket. What that will do is if you run check bucket in the container with a new random bucket name that you want to use, that'll tell you whether the bucket name is available. Once it's available, or once you find one that's available, you'll need to reconfigure the environment file. So you should reconfigure the environment file, then kill the container, and then restart the container by running run.shut again. Everything should then start up correctly once you have the right unique bucket name. Okay, so if we've got everything set up, let's move on to step 3 and take a look at the serverless framework. So I suppose the first thing to mention about doing deployments on AWS or indeed any cloud, but of course here we're focused on AWS, is that there's an enormous range of tooling, and that tooling is growing in scope and capability almost on a month-by-month basis. And all of these tools come under the heading of kind of infrastructure as code, or tooling to help with infrastructure as code. So those would include things like SAM, AWS SAM, Amplify, HashiCorp's Terraform, or the AWS Cloud Development Kit. For Ethereum, we've used pretty much all of them and in various different mixes. And they're all pretty capable tools. Generally, under the hood, they use CloudFormation, except for, of course, Terraform being the odd one out there. And of course, you can use raw CloudFormation using YAML or JSON if you wish. They just tend to get a little bit verbose, which is why we would recommend using something like CDK or Serverless Framework, of course. Oh, and you've probably got some comments on that, I think.
When it comes to developing this kind of application, particularly the kind of stuff we're talking about, which is, getting results quickly, getting from AI systems quickly, I suppose you want the tooling to get out of the way and do a lot of the heavy lifting for you. I think because we're using a lot of Lambda functions and we're wiring those into different event sources that trigger those Lambda functions, the serverless framework is ideal for that. And the AWS SAM would be an alternative that also provides those kind of higher level abstractions so that you don't have to configure every single resource required to get Lambda functions up and running. They give you the option to create really concise syntax and get it deployed pretty quickly. So this kind of example serverless framework is probably the best choice. The serverless framework, one of the areas where it really shines as well is that it's got a pretty big plugin ecosystem of plugins from the community. So no matter what your edge case is, if you need to work around specific AWS CloudFormation issues, that happens from time to time. Serverless Framework has you pretty well covered.
So let's have a quick look at what Serverless does under the hood to accomplish its magic. So I've got a little diagram here that kind of depicts that. So what we're going to do in a moment is look at some serverless configuration and run a deployment. And what's going to happen then is the framework is going to take this YAML configuration and compile it into a CloudFormation template. It's going to push that template then up to CloudFormation and then allow CloudFormation to do the heavy lifting of deployment of artifacts and so on in AWS. What it's also going to do, in the case where we have defined Lambda functions within the serverless YAML, is going to take that code, bundle up all of the dependencies, push those into a deployment bucket from where CloudFormation can fetch the bundled zip deployment and deploy it into the actual Lambda function once it's created the container to hold the code. And of course, it's not just Lambda functions. You can deploy any AWS infrastructure can be deployed through the serverless framework. It's really a question of whether you should use the serverless framework in a particular context or whether another tool is more appropriate. Typically, I think I would err on using something like CDK for underlying infrastructure, so VPC configuration, that kind of stuff, and then serverless framework for things that look like microservices, so where you're bundling code and functions that actually own a particular resource. Owen, you'd be a similar mind there, I think, or do you want to add any caveats to that?
Yeah, I think so. Pretty much, CDK shines where you've got anything dynamic. So if you have variations between environments, or if you have code that needs infrastructure that needs to be dynamically generated based on any given number of inputs.
Yeah.
So that's where CDK is really good. You use it quite a lot for deployment pipelines, where you might be automatically generating a pipeline for each service, and the number of services is going to rise and fall. Those is really good. But yeah, anything with a Lambda function, we tend to use Serverless Framework or SAM because it just reduces the amount of syntax. Now you can use SAM with CDK as well. You can mix and match these things too.
Yeah.
But I think Serverless Framework and SAM, they're similar in what they do. SAM is a little bit more rigid. I suppose being an AWS as opposed to an open source community project, it's strict in its use of CloudFormation and its respect of the CloudFormation rules. And Serverless Framework tries to get around the rules a lot more.
Sure. Yeah. No.
So it's more flexible, but as a result, you sometimes end up on a kind of dark, unsupported.
No, I think that's a fair comment. So what we have here is just a very simple serverless configuration file. So it has a provider section, in this case AWS, of course, a named runtime, a stage, and then a region to deploy to. And in this case, it's just the simple handler function, hello, and that's triggered by a HTTP event. And if we were to write this, the code for this function, it would look a bit like this. It's just going to respond with the string hello in a JSON message body. So that small amount of code will actually trigger the deployment of both a Lambda function and an API gateway into AWS. So really, the serverless framework you can think of as a kind of domain-specific language, which makes a bunch of configuration assumptions for when you're deploying your code. Okay, so let's move on. Now we've had a look at how serverless works, or the serverless framework works, sorry. And let's go ahead and deploy some infrastructure. So let me go back to my code window here. So in the repository that you cloned, you should find a directory called system. And under there is all of the code for our system that we're going to be deploying. So if we look in the resources directory there, you should see a file called serverless.yaml. And this is the serverless configuration for our underlying resources that we're going to build the application on top of. So let's go through this in a little more detail. So at the top, we have a custom section. And in there, what we're doing is importing some environment variables. So these environment variables were defined in the container environment. So we went through that a little while ago. You create an environment file, you set your bucket name, my crawler queue and my analysis queue are already set, and you have a default region and your AWS account ID that you would have configured in there. Okay, so then we have a provider section, so naming AWS and the node 12.x runtime, and we're setting the region there. Notice that the configuration here is this syntax means use this environment variable as a default region, but if that environment variable isn't set, then default to EU West 1 if that environment variable is missing. Okay, then we have
Can you increase your text size a little bit in the terminal there, Peter?
Okay, so then we have a resources section, and in the resources section, in this configuration, we're defining a bucket. So this is our bucket definition here. We're defining a bucket policy, and then we're also defining two SQS queues. So one is the crawler queue and one is the analysis queue. In this context, what we're doing is defining a bucket with public read because we're going to publish our API and our front end out of it. Owen, you want to make a comment on public buckets?
For cases like this, when you want to demo, you want to serve some HTML or a web page quickly, and that's the only thing in your bucket, and you're just giving read access publicly. That's fine, and just get rid of it afterwards. But in general, public buckets are something you should be watching out for and alarming on in your system. It can happen accidentally. There have been many public examples of data breaches because of buckets being left open. So you should be scanning for that kind of thing.
100%, yeah. But in this context, it's fine because it's only read access that we're giving. And also, we'll be tearing the system down after we've put it in place. Just to caveat that and make sure generally you don't use public buckets. Okay, so what I'm going to do then is switch back into the container. Let's clear that cruft away from there. I'm going to cd into the system directory, into work/system. And in there, you'll see all of the code for our system there. So home dev work system. cd into resources, and you'll see we have the serverless configuration file that we had before. So what I'm going to do now is just deploy those resources. So I'm going to run serverless deploy, and that's going to run the compilation process that we spoke about earlier, compiling some CloudFormation template, pushing that up, creating a stack, and then deploying all of the resources associated with that stack. So that's going to run away there in the background for a moment. And when that finishes running, we'll take a look at what it's actually gone and deployed in AWS. So what we're doing in this step, if we look at the code again, is there's no Lambda functions being deployed. We're merely deploying underlying resources in this step. So if I go to CloudFormation whilst that's deploying, we might just see what's going on as it deploys. I've got a new stack created in this account called resources dev, and that's showing that it's got an update in progress. So if I click on that, I might even be able to see the events as they play through. It's finished. Okay, so that's finished updating. So if we come back to our container now, we should see that indeed that is completed. So let's go and quickly check in AWS that everything that was in there was created correctly. So first of all, let's take a look at S3. And if I do that, we shall see shortly, there's my bucket that's just been created. And if I go to, what you'll also note as well is that there's another bucket being created there. And this is an artifact of the serverless framework. Every time you deploy something into serverless, it'll actually create a bucket and then use that bucket to communicate all of the changes and templates that it needs to CloudFormation. Eóin, do you want to give the pro tip on how to improve that workflow? The annoying piece where if you don't configure serverless framework correctly, you'll get a plethora of buckets being created for each deployment.
One of the good things about serverless framework is that it kind of manages that for you. The creation of the bucket it needs to deploy, your zipped up Lambda functions and CloudFormation templates. One of the things you can do is add a deployment bucket configuration, and then just use one bucket that you pre-create and manage yourself for all those deployment artifacts.
We've got our two SQS queues deployed as well, and if you go to the console, if you're working along or if you work along later, you should see them deployed there. That's some underlying resources deployed.